We will be offering professional development hours for this webinar. If you would like to receive professional development hours, please send Mike Trojan an email, and his email address is listed there. We will offer 1.5 professional development hours. And this PowerPoint presentation will be available in the Stormwater Manual. It'll be posted after this webinar is concluded. If you go to the Stormwater Manual Table of Contents page, scroll down to Communications and Outreach, and then click on Stormwater Manual Webinars, and you'll see the PowerPoint. You'll be able to download that. We were going to try and do a poll. Maybe some of you have been to one of the Chesapeake Bay webinars. They use a technology called GoToWebinar, and the MPCA doesn't have that technology. We're using WebEx for this webinar. We weren't able to quite figure out how to do a poll, but we hope to do a poll in the near future. So instead of the poll, we're going to be sending you a survey after the webinar, and we're going to ask you a couple of questions like who you work for, how often you use the manual, what your interest is in the MIDS Calculator workshop, and how this webinar went.
Okay.
I've got to go so we will be having some future webinars here. In mid to late January, we'll have a webinar on the new information on rainwater harvest and use. And in mid-March, we'll have updates to the Minimal Impact Design Standards calculator. And we'd also like to know what topics you're most interested in.
I should watch the reuse one. Oh, awesome.
So again, everyone, if you could please mute your phones. We are hearing some people talking in the background, and I believe it's frustrating for the other people trying to listen. So this is where, in the Stormwater Manual under Events, this is where we're going to list the future webcasts. So check that periodically. All right, with that introduction, I am going to turn it over to our presenters today. We have Greg Wilson from Bar Engineering. Bar Engineering did a lot of the work for us on this portion of our Stormwater Manual updates, and Mike Trojan with the MPCA Stormwater section.
Okay, is that me then?
That's you then.
All right. Again, please a reminder to mute your lines. We're still hearing a little bit of background here. I'm kind of excited about this, kind of nervous. I guess this is our webinar. We'll see how it goes. We're doing webinars instead of live presentations because we'd have to add a half hour to the live presentations for everybody to stop laughing after seeing my picture. But I'm gonna kind of go over the work order that we had here and then pass it on to Greg, who's going to do the bulk of the discussion regarding the work itself, and then towards the end we'll take questions. Please send in questions, type questions in, and Ann will monitor those as we get them. So I got the button here, is that right?
Yep.
I gotta go up here. So those of you who stay in touch with the manual and with us know that we've been doing a lot of work on stormwater infiltration over the past couple of years. It's obviously an important topic for a number of reasons, including it being written into our construction stormwater permit. You'll notice there are a couple new pages in the manual. The upper right has a page on stormwater infiltration that's been in the manual for quite some time now, but it addresses a lot of infiltration-related topics. There's also a page in the lower part of the screen called Stormwater Infiltration Best Management Practices, and it's the area shaded in yellow that we're going to primarily be focusing on today, and that would be infiltration trenches, basins, and underground infiltration. So we executed a work order. Got to do two things here at one time. We executed a work order with bioengineering to do the following: to provide new information and update existing information on infiltration practices in the manual, with a focus on infiltration basins, infiltration trenches, underground infiltration, and dry wells. This information had not been updated in the manual since the original manual written in 2005. And to ensure consistency between all infiltration best management practices, not just these, but also bioinfiltration, permeable pavement, and so forth. As I mentioned, our contractor was bioengineering. Greg Wilson was their project manager. The top 4 people, Greg, Matt, Michelle, and Heather, did most of the heavy lifting on this, but Bar brought in a lot of people to help at various points in this, and we really appreciate their efforts and work on this. I'd like to thank our technical support team. With many of our larger projects for the manual, we put together technical support teams. These are people who volunteer their time to review documents, to meet when we have an occasional meeting, and discuss the material as it's being developed. Lois Eberhardt, Jim Hafner, Mike Eisenseat, Karen Jensen, and I believe Joe Mulcahy also pitched in from Met Council. Forrest Kelly, Randy Neprash, and we'd like to thank again those people for supporting this effort. So the scope of work for this work order was to update the following pages in the manual. Again, focus on infiltration trenches, basins, and underground infiltration. Update the page on the overview page, types of infiltration, design criteria, construction specifications, and operation and maintenance. 2 new pages were created, understanding and interpreting soils and soil boring reports, which we think is important information, and then also some case studies for infiltration, and then updating the information on cold climate suitability in the manual. So today, the bulk of the presentation is going to be on the summary of the information that has been delivered to the MPCA by BAR. I'll do a real quick tour of the infiltration section of the manual towards the end. Spend 1 page on an update that's been made in the MIDS calculator to include an underground infiltration best management practice, and then we'll do a Q&A session. During the presentation, keep an eye out for these signs. The green, whatever you want to call that symbol, says new. That's new information that was not in the manual previously. Then there's an updated box that shows information that was in the manual but has been either changed or updated. And then a lot of the stuff has not changed, and I think it's important so that you don't think that everything that you're seeing today is new, that there's a lot of information that was very sound in the original manual and has not changed. So with that, I'm going to pass it on to Greg, and he's going to walk you through the information related to the material that I just talked about.
Greg? Yeah, thank you, Mike. First one listed here is bioinfiltration, and we'll talk a little bit about how we distinguish that from biofiltration, main difference being that we have a practice that will infiltrate water, whereas the filtration practice won't. And then we've got permeable pavement. As Mike talked about, there's a few things that have been updated: tree trench, tree box, and permeable pavement. Swales with check dams was not in the manual before, is in there now. Then we've got your traditional infiltration measures based on, as well as more information about design, construction, operation, and maintenance considerations for the infiltration trench, the infiltration basin, and underground infiltration. As Mike talked about here, we've got infiltration and bioinfiltration. I think there's some things that were brought into this version of the manual that are kind of distinguishing bioretention practices, those practices that don't infiltrate, from the infiltration measures. And I think I know you wanted to say a couple words about those exceptions.
I just wanted to mention that the bioretention page was updated about 3 years ago with work done by the Kestrel design group, And that page is in pretty good shape, and it was used to kind of help guide us on the infiltration work, which we've really been focusing on since then. So this page has actually been out there for quite a while, but it's the infiltration stuff that we're really focused on with this work order.
Thanks, Mike. I think the other thing to recognize is we have a couple of schematics here in this slide, A, B, C, and D, and what tends to happen with the sections of the manual is that these are utilized consistently to try to provide a visual for how these look different.
I accidentally.
Okay, and so that is another way to guide your navigation around on the on the pages on the website. So I think with that, I'll move to the next slide here. There's a couple things that we do mention in terms of where these infiltration practices are going to be applicable. Some of this is to assist with compliance on the construction stormwater permit, and some of these others are just good practices to avoid hot spots or sources of contamination to groundwater. And so you can see there are instances where infiltration practices would not be appropriate for industrial areas, as well as some of the other exceptions for having underground infiltration basins in highway road areas. So as I talked about before, we've got these schematics, and basically the way that it's organized in there is actually a link to this, a larger version of this table on the site that really just categorizes each one of the individual stormwater BMPs, and then you've got different design elements that are broken down for each one of them in terms of what kinds of pollutant mechanisms they have, where they might be in a treatment train, the amount of pollutant removal that you can expect, and then maybe land where the applications are appropriate or not. And so then each of the individual practices are broken down in this way. As you continue to move to the right-hand side of the larger table, you will be able to get more information about the expected costs based on the water quality volumes, the maintenance requirements that might be involved, pre-treatment that you will want to implement, and then what you can expect in the way of habitat quality from each one of these practices. Some of the design elements that come into play here have been revisited in the previous version of the manual. Most of these elements, in fact, contributing area was one of the first things you would notice and when you were looking at the guidance. And so we've gone back, revisited these elements, design elements like this. Contributing area was one that did get a lot of attention from the technical team and our staff internally. And so we kind of went back, and what we did with this design element as well as many of the others is to look at literature, kind of look for updated literature, and also try to substantiate some of what was in the manual before. And what we tended to see is that there's a lot of guidance out there, but it's very hard to figure out where the original guidance came from. You know, what the original citations might be, and this is actually one example of that. So you do tend to see that there's wide variability in contributing areas, and what we've kind of tended to do is err on the side of caution, keep these contributing areas to a smaller level. But on the right-hand side, you will see notes that what we tend to say is that we rely on making recommended or highly recommended elements of the design to be based on how well these features do drain within the desired time frame. So that being the key for all infiltration practices is that they have to infiltrate that water quality volume within the right time frame.
If I could just make a quick point here. You'll notice that the contributing areas are all in acres except for tree trenches, tree boxes, and the reason being that we're talking about a tree which needs a certain space to grow in, and so that contributing area is based on the area that tree needs to grow and become healthy and effective.
Thanks, Mike. Move on to the next slide here. Another element that is design element that's taken into account for each of these practices is site location or minimum setbacks. And so we've kind of got different features here vertically or horizontally, whether you're looking at the distance from the the high water level, groundwater level, saturated soil, wanting to be 3 feet or more above that, or bedrock. And then also horizontally, how far away you are from a structure. There's some guidance in there for that, 10 feet in this example here, as well as sensitive wells and surface water features, septic systems, slope and karst features. And so there's each one of these elements, in some cases they are footnoted to try to provide more detail deeper in the guidance. And then some of these terms are defined as well. One thing that we did revisit was in talking to our technical team, as well as just feedback that Mike was receiving prior to work on this study, was that in the past the manual had defined the term bounce. That also provided a definition for water quality volume, and that D-naught term that's in this figure here. But what our stakeholders were telling us was that the drawdown depth, which is not a defined term, and we didn't define it here, but what we were hearing is that what we tended to see is the outlet, or the control for any one of these features, a lot of times it was creating a lot of extra bounce. And so as a result, it might take a long time for the drawdown depth for you to get drawdown to like a 48-hour time frame. If that was what was desired in the past, a lot of folks using this guidance were designing things in such a way that the water quality volume would be depleted within 48 hours. And what we heard was that our stakeholders preferred that the entire feature be drawn down within 48 hours, so that if somebody did have pretty high bounce in their feature, that you would still have a dry basin within the desired time frame. So this figure is in the guidance and is intended to kind of provide some more background on what's intended when we do actually go in and for different soil types define what we think the infiltration rates should be, or in this case the drawdown time, or drawdown depth needs to correspond with that time, that 48-hour time frame. So here's some more features that were taken into account and guidance was revisited, including slopes to the contributing drainage area. There was no change there. Infiltration rates, no change. And so these features did not change. Our guidance about karst about not using these features in karst formations, and then diverting the water quality volume to the practice and providing bypass. Unless, like I said, it is actually designed to contain all of that volume and infiltrate it.
Greg, if I could just make a point here, I hate to back up, but in the previous slide, it was mentioned about getting the full volume of water out of that system. I should mention that that is a permit requirement. So,
great. Thank you, Mike. So then the other thing is having infiltration systems that do not have an underdrain. If you have an underdrain, then we're really talking more about a filtration practice. Pre-treatment, there is short guidance on what to assume for that. I think this will be another a future topic for Mike's group. And
yeah, I'm not sure if we're going to make it a topic, but it might be part of a webinar. But the pre-treatment section in the manual has also been updated, and so I would recommend that you go to that section in the manual.
Longitudinal slope of the practice, ideally there wouldn't be a slope, but 1% would be allowable, and same for the lateral slope of the practice. I think I'm off the... Okay. I'm going to bring this up. What we have is a graphic on the left-hand side. This is to provide, and don't expect anybody to see this, but this has been revisited as well. Mike's group through the Minnesota Department of Health have updated the stormwater guidance for sites with drinking water supply management areas. And so this kind of gets at that wellhead protection side of the infiltration practices and what to do, what to consider in that regard. I talked earlier about the drawdown time. So we've got maximum side slope practice slope guidance here, but then we also have this individual guidance based on soil type for drawdown time requirements, with the intent being that we wouldn't have a practice that's more than 6.5 feet deep, so that we can make sure it does drain dry. Like Mike said, it's a permit requirement. And so, but if you've got other soils, then that means that the drawdown time requirement is going to affect how deep the maximum depths can be for the various soil types. So that's been updated in this version of the manual. We also have more information about landscaping and integrating vegetated areas into the planning process, what's recommended for that, collecting vegetation based on their tolerance to water, native plant species and highlighting the preference for that, what types of other vegetation you should consider in these practices, and keeping woody vegetation out of pretreatment devices to not hamper the maintenance of those. Discussion about planting trees along the perimeter and not over-under drains is highlighted, and then using salt-resistant vegetation if necessary. So we've got other information that's recommended for plugs, bare root plants, potted plants, or sod. And then operating vegetated practices offline until vegetation is established. There's a guidance on that. And then how much plant coverage you should have within different time frames after these practices have been constructed. Snow considerations is another, I guess I would say this is fairly new. Some revisions have been made to this, as well as updates to what was there before. Planning a plow path during the design phase is one. Telling snowplow operators about where to push the snow, and planting trees around the plow path with a minimum distance between the trees. And then bioretention should be a last resort for snow storage or because of concerns about emergency overflow. And then snow storage could be used for pre-treatment mode around the rainwater garden.
Greg, could you just touch real briefly? We get this question a lot on whether snow can be put into these best management practices. Can you maybe just comment a little bit on that and why you're saying rain gardens should not be used for that purpose?
Yeah, I think the concern comes from, similar to why we don't want to store water or much higher levels of water for longer periods of time, and this is in some ways similar to that in that we're getting more compaction of the soils if we do a lot of snow storage in the practice, or if we have excessive amount of water storage in these practices, and that appears to be affecting the long-term success of some of these practices and its effects on compaction. So we've got a really big table in the guidance manual that kind of provides some information about infiltration media and material specifications. And I'm not sure if we want to, if there's time to show.
Yeah, I think if you want to
try it,
just scroll through this table. Again, a lot of this is.
Go back one.
Okay.
A lot of this is just to show you stuff that's in the manual now, and rather than getting into the weeds on a lot of this. But this is a very informative table, and as Greg says, it's a very long table too. So.
Yeah, and then in this instance, we have different design components that are make up each row in the larger table, and then each of the individual practices that we've talked about for this part of the manual are representing column. And so a lot of times these practices have similar design components and similar specifications are being suggested here. What I will point out is you'll see the hyperlinks here do go straight to MnDOT manual sections, and we did this on purpose. Our technical group expressed a desire to do this as a way to sort of maintain some consistency, so that realizing that a lot of people in Minnesota at least are going to use this manual as a reference, and we want them to be able to, we want to point them in the direction of where ultimately the final reference might be, and in this case it could be a MnDOT specification. And so that is available as you scroll through that, and then you're just kind of able to get more information about what kind of surface cover you should have. Again, you'll see for each individual practice there may be a MnDOT spec that's applicable, different layers that come into play, what to consider for each layer of the practice, from the bottom to the top essentially, as well as vegetation. And then other information that pertains to construction activities, what to consider as you're constructing these practices. So I think with that, we'll go back to the presentation if I can. Two new media mixes were added to what had previously been in the manual for infiltration practices. And in large part, these were done on purpose, to the intent being that that we'd have some options that might improve plant health in infiltration practices by adding more soil mix options that have greater amounts of organic matter that wouldn't break down as quickly as some of the compost might otherwise break down, as well as providing finer loamy soils for a greater water holding capacity. So there are two new mixes, E and F, that are available and cited in the manual as well.
If I could just interject, just to remind folks that this media issue has been important. We are talking about infiltration practices here, so these high organic media are of less concern. When Kestrel did their work a couple of years ago, we made sure to add a couple mixes that had lower organic matter content for those systems that have an underdrain, because these systems, if you have higher organic matter media, you're going to leach phosphorus, and if it's going to an underdrain and back into your storm sewer system, that's of course problematic. But since these are infiltration practices, we're not as concerned by the higher organic matter content.
Thank you, Mike. On to the next slide here. Another thing that was desired as a part of the updates to the manual to delineate the 9-step process, get people thinking about you know, whether or not.
She's 80 years old, and she got on this Match.com.
At 80?
And they got married.
At 80? How old was this guy?
Like 81 or something like that.
So she'd obviously been married before and her husband died, or?
Yeah, this is Trudy's.
We're getting a lot of noise,
her husband's
please.
father died a couple of years ago, and she wanted this companionship, and so she, and this other guy, he lived in Burnsville or something. I guess he's still working.
We're
He's still
kind of,
Medicare insurance or something like that. And anyway, it was that's what one you use, right? Match.com or again. And hooked up, and they ended up getting married there.
Again, please check to see that you're muted. We're picking up some conversation. Unless you're inviting us out for drinks, we're really not all that interested in your conversation. Thank you.
All right. Well, I'll try to continue here. Our design step process tries to get people thinking about their site conditions, whether or not it's appropriate in the first place for infiltration, and how that might fit into your treatment system if you've got a treatment train essentially. Determine if you are subject to the construction permit requirements and what might apply from an infiltration practice standpoint. And then verifying your soil properties. And so there's suggestions in here for, depending on the surface area of your control measure, how many borings or pits you would put in place to check for infiltration, as well as the permeameter tests. I think that, yeah, I mean, basically this corresponds to each of the areas that are shown there. And if you get larger than that, there would be some limits to that, and so we've got more guidance on that.
Yeah, I'll show this table again later, and there are some footnotes there, so I'll touch on that when we get there.
Great. The fourth step was to compute runoff volumes, determine if the 1-inch construction stormwater permit applies. Selecting your design variant, what practice are you using and how to size that. Look at your area, your runoff volume and depth that you can maintain or that you can support. How you're going to size your outlet and flow diversion structure so that you can meet that drawdown time that we talked about earlier. And then performing groundwater mounding analysis. I don't know if this, I know mounding you were going to talk about later, Mike, as well. There's some more guidance on doing this analysis in the manual, and you might step through that.
Yep, I'll talk about that in a later slide. Thanks.
Yep. And then determining what your pretreatment volume should be is the next step. And checking your volume peak discharge rates and your drawdown time. Making sure you're within guidelines on that. Preparing your vegetation and landscaping plan and your operation and maintenance plan. And then obviously looking at your costs, depending on where you are in the design process. Construction specifications was a new element of the manual this year. Try to get more guidance in there about access agreements and adding sections that define easements that might be required that get you considering what's required in the way of access agreements. Specifications, revisited the construction specifications. Like I talked about earlier, making sure we're getting links to MnDOT specifications wherever possible. Getting you thinking about pre-construction meetings and walkthroughs when you actually do start to construct the practice, and those other things that you need to consider along the way as to when the timing of protecting the site, getting your pretreatment in there, your erosion control, and then making sure that the contractor avoids compaction of the practice as much as possible. Inspection and documentation, we include checklists for each type of practice. There's individual checklists for each type of practice to kind of give you guidance on what to look for as you inspect and document the construction of the practice. We also, new this year is getting construction sequence information in there about examining and marking your spot and laying it out before you start construction. What to follow and best practices for excavation and decompaction if you need it, if you do tests and determine that you need that. You know, things that you can do to do that down to an 18-inch depth below your subgrade. Subsoil infiltration testing to ensure that your drawdown time is met. And then the installation of the materials and media. Best practices for that and restoration and planning, as well as what guidance you might want to consider for stabilizing and closing out your project. So here we've got our next step in the process of updating the manual material is to consider the design and construction phase considerations. Maintenance burden we've determined that the maintenance burden can be minimized by considering these design criteria. Limiting that drainage area to the BMP, like I said, that varies depending on which practice you're talking about. Providing the site access that you know you're going to need in the future, as well as pre-treatment, and then what kinds of native plantings to utilize. And then inspections during the construction process to ensure that your infiltration practices are built with the approved standards and specifications. Should we go to the link in the manual for that, I guess?
On here?
Yeah, go ahead and give it a shot.
That's what you want, right? That's what you want, right?
So these are examples of the checklist that I talked about. We've got you've got this also in a table version, or you can create an Excel version of the form. But for each, it's essentially set up so that you can reproduce this for each project, each site that you're working on. The considerations that you would have that you would want to document as you evaluate the construction of these practices. What you're going to cover in pre-construction, what you're going to look for during the excavation. What structural components you want to document, as well as the vegetation and making sure that you're meeting specifications on that. as well as the final inspection and closeout of any given project. And we've got post-construction operation and maintenance considerations. So these have been updated as well in the manual, and revisited maintenance plans now include inspection and maintenance checklists, operating instructions for the outlet component, and then your maintenance schedule for vegetation.
Thank you.
We have also provided some examples of legally binding and enforceable maintenance agreements. I think we had at least 3 of those in the manual from different entities here in the area that have a lot more experience with these practices. What's important in these agreements? So there's a few examples to consider in there. And then making sure that you have adequate access and are avoiding compaction, and like we talked about earlier, snow management, those considerations, those are highlighted, as well as maintenance activities in your schedule.
You've seen that before, though, right?
So the typical maintenance regime has been updated.
Good.
If vegetated, we know you're going to want to water the plants for the first year after planting. And then as needed, consider weeding and pruning the vegetation, stabilizing your mulch and vegetation, removing trash and debris, and then mowing any filter strips that you might have. On a semi-annual basis, suggested that you inspect the inflow, pretreatment systems and filter strip, as well as removing or replacing vegetation as needed. The manual provides more guidance on each of these, so includes some estimate for hours in performing these activities, so you can kind of plan out what, some of these other factors that need to be planned out in advance. So some of the typical maintenance problems have been documented in this version of the manual. This is new information. Thinking about, well, depending on what your focus is, whether it's the drawdown time or the drainage area, we've got different maintenance problems that could come up, and so we categorized it by that. Or if you're looking at pre-treatment portion of the system, or even site erosion following construction, what are the maintenance activities? We've got these individual maintenance activities for you to consider, as well as what that schedule might be for each one of those activities. That so suggestions on how often to consider each maintenance activity is included in the manual now. So we've got also an example list of standards that we talked about, these maintenance agreements, the examples that we've provided. And so these, right here, we've got 9 examples of standards that you may want to get into that maintenance agreement. And I'm not going to read every one of these, but I don't know. I think it's suffice it to say that these examples that we put in, like I said, have been developed and probably modified and remodified based on each individual's experience with making sure that these practices are successful long term.
As Greg mentioned, there are examples of these maintenance agreements in the manual now, and so you can find these types of lists in those maintenance agreements if you go into those.
I think we'll turn it back over to Mike to talk about soils.
Well,
soil borings.
Maybe before I go on, were there a couple questions, Ann, that it might be a good time to take a break here?
Yeah, if you do have questions, please use the chat box to ask the questions. I know there were a couple. Okay, one question is, why do you need 3 feet of separation from groundwater for infiltration, but in the same pond footprint, you can do wet pond construction, which is in direct contact with groundwater?
Yeah, I mean, most of the time these wet ponds are either have material that's impervious or, like you said, has a liner, and so then it wouldn't be a threat to groundwater supplies. Whereas the infiltration practices, the expectation is that we're going to replenish, we're going to to percolate that water into the ground, into the groundwater supply areas.
That was it.
That was it right now? Okay.
Okay, good. Okay. I'm going to talk a little bit about understanding and interpreting soils and boring. We felt this was an important topic. We had heard from a number of folks that a lot of these systems that, again, a reminder, please to mute, thank you, that a lot of these infiltration systems were failing, and that possibly the reason was that the initial assessment or analysis of the soils that were in the management practice were diagnosed or incorrectly determined. And so the goal, I'll point this out here, states that the goal of borings for infiltration practice differs from the purpose of collecting borings for structural engineering purposes. With an infiltration system, we're primarily interested in the presence of restrictive layers, no matter how thin they are. There's some good information in the manual, including a little video that we accessed from another website that shows water infiltration into a soil, even with a very thin clay layer, and how that clay layer can really impact the infiltration. So if you have any restrictive layer at all in your system, it's going to really cause some problems if you've overestimated the infiltration capacity of the soil. Do I?
Here.
Not have control?
I was just muting. Okay.
Okay. Greg showed this earlier, and I'm not going to spend too much time on it, except that there are a couple footnotes that didn't show up in Greg's table that he showed earlier. That as you do increase the size, there are additional recommendations for the number of borings and pits. So for every additional boring that you take, for every additional 2,500 square feet of size, we recommend one additional boring or pit, or an additional 5 permeameter tests for each additional 5,000 square feet above 15,000 square feet. Should also mention that we do prefer in situ permeameter tests to borings, but we realize that borings are typically the mechanism that people use to evaluate their soils. There are different types, and I'm not going to talk too much about this, but I'll go right to the table, I think.
There's one question that just came in about this.
All right.
So a question came in just now about this topic that Mike's talking about. Is there an example scope of work that would describe what a boring consultant is to gather the required documentation necessary for design of a SWIP?
Well, for design of a SWIP, I'm not sure that there is anything for that specifically, but there is definitely guidance in there for the types of information that we believe you will want to collect from your soil boring. So there's actually an example boring logs in the guidance, and the kinds of information that you want to collect are included there's a breakdown of that for each type of boring.
Yeah, and we'll walk through that here in the next few slides, and hopefully that answers the question. But there is a tremendous amount of information now that has been given, that's in the manual on this particular topic, and I think it addresses the question. So
we can illustrate that later.
Yeah, if I can get.
Do you want me to go to the table?
Yeah, if you could go to the table. So here's an example of a table. It's in the manual, maybe.
Go.
There we go. So this discusses the 6 methods for collecting soil samples, soil probes, handheld augers, and so forth, test pits. And this table will give a description of each of those methods. It'll tell you the type of sample collection that's possible, the maximum depth that you can get to using that particular method. So for example, you can't go below 3 feet or 5 feet?
3 feet.
3 feet, I'm getting old. I can't see the screen too well, but 3 feet with a soil probe. I've actually collected soil probes down to 4 or 5 feet when I was much, much younger, and it's not much fun. But yeah, you are pretty limited with that particular method. Advantages and limitations of each method, and then some photos and references that you can go to for further information. So, yeah, if we can go back to the presentation. Disturbed versus undisturbed soil samples. A disturbed sample does not retain the in-situ structure of the soil. These tests can be used for classification tests. And I talked to Greg about this before, and one of the points that doesn't show up here is that, I'll mention it here, that split spoon samples are probably the best methodology for collecting a sample that will give the most relevant information for determining soil suitability for an infiltration BMP, because you can get good blow count information. Correct me if I'm wrong here, Greg. But you use that blow count information to help identify restrictive layers, which is what you're most interested in doing these infiltration tests. Undisturbed samples are recovered completely intact, and this gives an example of some of the samplers that you can use to get undisturbed samples, and they're generally not collected when trying to determine infiltration potential because they do not allow for flow count information, which helps you identify those restrictive layers in the soil.
There's another question that came in.
Another question.
What is the general thought of infiltration in areas that are in active karst features, less than 50 feet of soil cover, but is not located in the DWISMA or wellhead protection area? I've heard the term higher engineering review to determine if infiltration can be done in karst areas, but what does the higher engineering review actually consist of? Either of you know the answer to that?
I know where you can find that information in the manual, and later when we do the tour, if you can prod me into remembering, I'll go to the karst page and answer that question. Okay. How's that for a non-answer?
Okay. Can you use this back now?
Yeah, if I could.
Okay. All right.
All right. Drilling guidance. This is a long slide with a lot of bullets and small text. I apologize for that. But again, we think this is a pretty important topic because your infiltration system really it's going to perform only as well as the information that you use to design it in the first place. So, and collecting good soil information is critical. So if recovering a split spoon sample is less than 6 inches, drill 2 feet deeper and perform another split spoon sample. If a confining layer is found or there is low recovery in a split spoon, reduce your sampling intervals to every 2 feet. What we're trying to do is we're really trying to characterize that restrictive layer, because that's going to be the dominant layer affecting your infiltration. If low recovery is encountered, explain this in the field notes and explain why the driller thinks it's happening. Again, sometimes you can't avoid low recovery, but you need to know that you're getting low recovery if that's the case. Flow counts are found using a standard penetration test are critical to determining the presence of restrictive layers. If soil boring auger refusal is encountered prior to the depth desired, offset about 5 feet from the borehole and drill down to the refusal depth and continue drilling from that point. This will increase your costs, but again, this information is very important. If you continue to get refusal, talk to an engineer. Don't talk to me. Talk to an engineer and try to figure out what's going on, and at a minimum, describe that in your field notes and in the boring log. Ask the driller to include soil type, recovery blow counts, presence of water. I'll actually show an example field log here in a minute, so you'll see all of that. Although there's a tremendous amount of information you can include in these logs. It's highly recommended that drillers use a standard form, and I'll show you some examples of those that we have now in the manual. So I'm going to grab the mouse here and go to some of these. So information to include on a boring log, here's a couple links. A link to the table showing you the information you should collect, and then a link to some example boring logs. I'll take you to both of those briefly. So information to include in a boring log, you can see there's a pretty extensive list. The item to include, a description of what that item is, and then an example or photo, and links when appropriate. So I'm not going to go through all these, but obviously boring name, project name, things like that, but drilling methods, sample recovery, color, soil density, grain size, blow counts, depth to groundwater, lots of information that we recommend that you include in this boring log. We give some example boring logs here. Ooh, okay, that's a surprise.
Oh.
Well.
Your graphic does have some of that.
I can maybe get, you know what, when I do the tour later, I'll show that. And that
shows some examples.
Here's an example that's coming out of the manual. It's pretty fuzzy, but we have 5 examples, I believe, 3, 4, or 5, or whatever examples of boring logs in the manual. And hopefully I'll get to the right page later and be able to show that to you. There's also some additional information on this. What samples might you want to collect for laboratory testing of? Particle size distribution is one that is fairly common and potentially very important. There's also some discussion of restrictive layers in the soil in the manual now. Discussion of soil exploration reports and lots of reports.
Careful.
And links.
Nice.
Yep, sorry.
Can you go advance your slide?
Yeah. Greg had mentioned we now have a full page in the manual on groundwater mounding. If you're in the manual and you hover over up in the upper right, you see page contents. That will show you the table of contents for that page. And so mounding has always been in the manual since the original manual. It's been recommended that you do a mounding analysis. I've talked to some of our engineers here, and they almost never see this actually done. In practice, it's pretty easy to do a mounding analysis, and this page would be a very useful tool for you if you haven't done them before. The USGS has put together a very simple spreadsheet in Excel format that's accessible, and it's on this. The link is on this page here that you can use to conduct a mounding analysis. This page will tell you when is groundwater mounding a problem. So for those of you who aren't familiar with groundwater mounding, when you infiltrate water, you're going to raise the height of the water directly below that infiltration system temporarily until it disperses laterally within the underlying groundwater or soil system. And so that's the mound that's developing underneath. When should you do a mounding analysis? How to predict the extent of the mound, that's the USGS tool I alluded to. A guide to using that calculator with some examples and various different scenarios and some actual case studies. So the mounding information in this is very useful, and we really recommend that folks start doing that when possible. Another page that was added to the manual, so I'm kind of done with the boring stuff now. People would say I'm always boring, but soil boring stuff. There's also now a page in the manual called case studies for infiltration, and yeah, you can click on that just real briefly. There's just three case studies here, and you can see that there's information about the project, its location, the year it was completed, some cost information, I believe, maybe. Yeah, some cost information, the type of pretreatment, pollutant removal that's being achieved, and so forth. And so these 3 sites, I believe 2 of them are in Roseville and 1 is in Minneapolis. So if we can go back then quickly. We're always looking for good case studies. If you have some, please contact us and we can discuss them with you. We'd like to get more case studies, and we're always looking for good photos too. So of stormwater management practices, that is. We're not looking for photos of individuals, good photos, even if you have good photos, but never mind. So send them to us, good photos with the proper crediting for the photo. So I think with that, it might be a good time to answer
There's another question. In the chat box, does the manual address infiltration in D-soils as required by several watershed districts?
As Greg showed in one of his bullets earlier, you may not have seen it, but infiltration is generally not recommended in D-soils. Is that correct?
It is not, but there is guidance that gets at that. I think they have a place for it in one of the bullets there. But yeah, it definitely is not normally recommended. Okay. And so I suppose depending on where you're at, which watershed you're talking about, it either may or may not be allowed.
I don't know if that answers the question fully or not, but it's tough to get the desired performance goals in D-soils. So. And it can also cause some mounding issues too in those tighter soils.
It does give you links and references to consider alterations you might want to make, or go to biofiltration or filtration practices as well as modifications that you might make to overcome the presence of D-soils.
Okay. There's another question here about cost. So how much on average is the average square foot cost for installation and maintenance of this example system? I don't know if they were referring to one of the case studies.
Oh, one of the case studies? Yeah, I don't know if we have that level of detail for those case studies. We did have another slide earlier that provided the, based on water quality volumes, what the general range of cost was.
Yeah, I don't know
if I can find that.
Yeah, it was one of the earlier slides.
Yeah, so there, in this big table where we talk about properties of individual practices, we've got like an infiltration basin. We've got low costs, like a dollar to a little over $1 per foot. For infiltration basins or bio-infiltration basins, $1 to $4 a cubic foot for infiltration trenches, and dry wells like infiltration or soak-away pits, infiltration tubes, French drains. And then your underground infiltration's higher. It's like $14 a cubic foot. Is about the best guidance we had right now from a unit cost standpoint. But the case studies, yeah, I mean, I think you should have enough information for those to determine what a unit cost might be. We've got the total cost, and we've got information about how much area is being treated. So it should be possible to figure out what it was costing the project.
Do you see a lot of variability in the cost of these, and what are some of the factors that are most likely to drive up the cost?
Yeah, I think there is a lot of variability. I mean, if you do soil analysis and you see that there is a layer maybe that's going to affect the performance, well, then that could really affect the size, right? So unless you do something to overcome that problem, in some cases, if you've got a small lens, you might be able to plan for that or plan around that. If you do enough borings, you might even figure out that there's a better place to put your practice as well. So yeah, that I think is a big contributor to the variability. And then I think the other things that you have to plan for, pre-treatment, and just maybe site design would affect too the variability in the cost.
And I'm not a practitioner, but it just seems to me that maybe investing a little bit more up front might save you more in the long run too. If you get the soils wrong, or if you don't do adequate treatment, your system may not last as long as you expected.
Yeah, I think our technical team the feedback we got was that the soil boring information was really important this time around, because you get surprised otherwise if you don't have good information on the soils, and so having the best guidance available for that does have implications for maybe the long-term success, or as well as cost for what you're planning.
All right, next question. And thanks for sending these in, everybody. The next question is, it was mentioned that MnDOT grade 2 compost was not recommended for filtration practices due to nutrient leaching. Are there alternative recommendations other than peat moss?
I don't know that we were recommending a certain compost. I think what we're saying is the organic content of the media needs to be below some critical threshold. Would that be correct?
Yeah, I think you're right. I think, as I recall, that's what you were saying before.
I think in the work that was done previously on bioretention, we're looking at a peat content of about 30 milligrams per kilogram in the media. If you're below that number, I think generally we feel that it's pretty good for, it's not going to be leaching phosphorus. If you're above that number, then you're going to start to see phosphorus leaching out of your system. So it's more about the organic matter content as opposed to the type of organic matter. Although that is a topic we've talked about internally addressing in the future, that maybe we do need a little bit more information in the manual eventually on compost and media. So it's something that's on our radar screen, I think.
Okay, another question. Are infiltration practices still recommended near areas of high salt load? Something we're seeing right now.
Depends on what you mean by high salt loading, but I think the answer is we've updated the page in the manual on potential stormwater hotspots, and we've now included information along highly salted roads, and are calling those stormwater hotspots areas where you probably don't want to infiltrate. We don't have our groundwater person here, but I used to do groundwater monitoring, and I know that in residential areas you might see salt chloride concentrations in shallow groundwater of 20, 30, 40, 50 parts per million compared to, say, 10 parts per million in under native conditions. If you go to high density, high traveled transportation areas where you've got a lot of salting,
second footnote,
you see concentrations over 1,000, 5,000 parts per million. So in general, I think we're recommending not to do that. But Greg just showed something to me here. And what is it saying?
It's just saying that it can be okay with some of the smaller practices, but it would be limited for like an infiltration basin. There would be limits to what you would want to implement in those areas for that type of practice.
So yeah, I guess the short answer then is yeah, those practices probably are not recommended in real high salt application areas.
The terminology you'll see a lot in the manual is recommended, highly recommended, and not recommended. And so yeah, I think you've hit on one of the three there that folks will see, and then that's defined in the manual as well as to what that means for each situation. Okay,
there's another question. Does the PCA have a recommendation for when infiltration should not be used due to high blow counts / dense soils? What would be considered a high blow count?
I'll let you answer that one.
Yeah, I'm not the geologist that worked on that aspect of the project. I can't immediately tell you the number, but I know that, and maybe you'll actually come across this when you do the tour, but we do have, I know we have some information in there about that, so I won't be able to find it probably quickly enough. When you are doing the tour, maybe by then we'll have an answer to that question.
Okay, how about one more before we start the tour of the manual? Do you recommend vegetating large infiltration basins?
Does it matter?
Yeah, no, I think the vegetation is normally going to be recommended for any of these practices wherever you can do it. Obviously can't do it for permeable pavement or some of the underground practices, but yeah, it generally is recommended. There'll be guidance in there for how to specify. Take that into account for your specifications and maintenance.
I think there's a number of reasons for it too, and I think we're all focused on stormwater management here, and that's what we do. But I think there's a lot of other reasons to include vegetation in your practices too. Aesthetics being one of them, for example. If you're planting natives, pollinator-friendly systems are good. So there are other considerations and reasons for vegetating a system too. Okay, so we'll do our little tour now. So we're doing okay on time here, I think. So I'm just going to take you on a quick tour of the manual. I'm not going to get into all the little details, but basically just show you where some of the stuff is that was shown to you today. You probably get into the manual in a lot of different ways. I'm going to start at this table of contents. You can get there in a number of different ways using Google search or whatever. But if you're on the table of contents page, you can scroll down here to stormwater control practices. We're going to try to restructure this a little bit after the first of the year, but you can click on infiltration practices here, and it will take you to what we call a portal, which is basically another table of contents that links to a bunch of other pages. Pages that are shown in red don't exist yet, so these are things that are in the works. Live links are shown in blue. So these are all the different infiltration practices in the manual. If you want to get to the pages that were discussed today, you would click on this infiltration. It's the same page for trenches, basins, and underground, because this is a question we asked Barr early on in the work order is, do these practices merit their own separate sections in the manual, or are they similar enough to include it in one section? And the conclusion was they're similar enough to include in one section, but call out the differences between them when those differences come up. So you go to infiltration, it takes you to yet another portal with a whole bunch of links to pages that discuss the topics that were covered today. So this is infiltration. Sometimes you see alerts and photos and stuff. The pages that were updated through this work order are the overview, the types of infiltration, design criteria, construction specifications, operation and maintenance, case studies, and then the page on understanding and interpreting soil borings and soil boring reports. So I'll very quickly go through each of those. I'm not going to spend, like I said, a whole bunch of time. Just as for those of you who may not know this, you can keep this page open and open another page by right-clicking on this and then opening a new tab. So it allows you to have that other page still active. So the overview page is really just general information. Again, if you hover over the page contents, you'll see what's on that page. This overview page includes information on the function within the stormwater treatment train, its applicability to the MPCA permit, construction stormwater permit, retrofit suitability, special receiving water suitability, cold climate suitability, water quantity and water quality treatment, and limitations. On every one of these,
just hold on one second.
Yep.
Mike, I'm not seeing the actual manual on my screen. Could someone just let us know via chat if you're able to see the actual manual that Mike is showing? Because I just want to be sure, because I'm not seeing it on this other screen that I have. So if one person could just write yes. Okay, you can see it. Go ahead.
Okay.
Sorry about that.
Good. Boy, that would have been embarrassing.
Yeah.
Anyways, on every one of these pages, you'll notice at the bottom there's a topic called Related Pages. So that portal that I showed you here, right here, this stuff here, shows up in the Related Pages section on every page. So that's a good way to kind of move around. So if you click on that, it'll take you down to those other related pages. And so that's a good way to move around within a particular topic. And so types of infiltration, Greg talked about. This is a fairly new page. Again, the contents talks about the different infiltration practices, basins, trenches, underground systems, bioinfiltration, permeable pavement, tree trench, dry soil, check dams, which is just starting to get populated in here. And then those information tables that Greg showed, and I'll go through those a little bit. But if you went to any one of those BMPs, there's a short description of it, links to all the information, the other pages on that topic. So for infiltration basin, you can get to the overview, design, construction, O&M, and then a table over here that shows you its applicability and its treatment capabilities. And so that would be the case for every one of these infiltration best management practices, the same type of information. Bioinfiltration, for example, same type of table, but different, I'm sure, than the other practices. You scroll down to some of the information tables. Now, this is the stuff that Greg showed today in the presentation. This is where you find it. A lot of it is on the design page. A lot of the design, all of the design stuff is on the design page. So here's that table providing the general overview. The table providing the contributing drainage area. The table providing some of the treatment properties. Table providing some of the cost information. So this is where that question had come up earlier about cost, and this is where you would find that cost information on this page here. Design criteria page is very long, as most design pages are in the manual. Covers terminology, some CAD images and details. Then it goes through the major design elements, whether it's physically feasible at a particular site, do you have the right soils, the topography, and so forth. Major design elements considering the practice and site consideration. Do you need under drains? What kind of pretreatment do you need? What kind of landscaping do you need? Material specifications, observation well, the surface cover, filter fabric, in situ soils, and so forth. Media specifications, and then the design procedure that Greg talked about, steps 1 through 12. So again, I'll just scroll down the page real quickly here to kind of show you, again, some of the tables. The table on contributing drainage area. In the manual, for those of you who don't know this, you can click on any image, and it'll give you an enlarged image of that. And so that's a good way to get information, a good image for these figures without crowding the main page it's coming from. Separation distances, links to wellhead protection that Greg mentioned. There's the image on bounce that Greg showed earlier. And then the material specifications. A lot of this stuff is fairly short and brief and summary in nature. And here's that long table that Greg went to before with all the materials information in it. Here's the links to the different filter media. So one nice thing about having the wiki is that we can create a single page that deals with a particular topic, and we can link to that. We can take that page and link to it in any number of places throughout the manual. We only have to update that one page, and everywhere in the manual it gets updated. So a lot of times in the manual you'd simply be taken to links, which are a single page. Tables, again, I'll point out, are on their own page too. So if you were to click on this, it would take you to the page that holds that particular table. Information on the number of tests to take, and then the design steps here, 1 through 12. The construction page, as Greg mentioned, is fairly new. We did have a construction page in the old manual, but it was basically didn't have anything, didn't have much of any value. This page is different now. It's been populated with a whole bunch of new stuff. Construction specifications, pre-construction meetings, how do you protect your site using pre-treatment, temporary erosion, sediment control. How do you prevent compaction? How do you inspect it and document the site? And then the construction sequence. This compaction is a good example of, you'll see that there's one sentence basically telling you to go to this page here, which is a whole page in the manual that deals specifically with alleviating compaction from construction sites. Going on to O&M. When we see something good that other folks are doing, we'd like to link to it. The Chesapeake Bay has tremendous information on maintenance. Again, as a caution here, these materials, the Chesapeake Bay materials that provide useful guidance should not be used for compliance with Minnesota permits, but they have very good information on visual inspections and I recommend for those of you that are interested in that topic that you go see their material. It's very informative. On this page, you'll find information on the design phase, maintenance considerations, construction phase considerations, post-construction operation and maintenance, including inspections, planting, summary of
typical maintenance regime.
My glasses went bad on me here all of a sudden. Estimated hours to perform the maintenance activities, erosion protection, sediment monitoring, seeding, planting, landscape management, sustainable service life for infiltration and bio-retention BMPs, typical maintenance problems and activities, maintenance agreements, inspection reports, and then related pages. I'll take you down here to maintenance agreements. You'll see that there's 3 example maintenance agreements. If you go to one of them here, you'll see this is an example for the city of Burnsville. Maintenance inspection reports. We have examples for infiltration basins, bio-infiltration basins, infiltration trenches, and so forth on dry swales or check dams. The case studies, Ann already took you to that, so I'm not going to go to that now. I will go to the soil boring page. So this has got a lot of information also, number of borings to collect, the historical information you should collect at a site, typical soil collection methods, disturbed versus undisturbed, all the stuff that we covered today, how to order a soil boring, information, I can't read that.
Information gathered from soil samples.
Information that you gather from soil samples. So that's that table that, well, I'll go to it here in a second. How do you interpret soil borings? Samples that you might want to collect for laboratory testing. How do you determine the importance of restrictive layers in soils? Soil exploration reports, and some additional resources. I'll go down to this here. Information gathered from soil samples. So this is all the information you might want to include on a boring log, and it talks about it in this table here, the information, what it is, and an example of it. And here are those example boring logs that we talked about earlier. So there are 5 of them in the manual. Again, just click on one of them to get the larger image. Restrictive soil layers, and then, okay, so I think there was one other question, 2 questions about blow. Remember what the blow count stuff was?
Yeah, and I wasn't able to find that.
Okay.
I think we did have something in there, I just couldn't immediately find it. I think that one thing to keep in mind is you could have some of these tighter soils and not necessarily have a high blow count, and so you know, depending on what it may or may not be good indication of your infiltration potential in some instances. So,
well, here on the table it talks about blow count, says the number of hammer blows to pound split spoon, 6, 12, 18, and 24 inches into the soil. It doesn't really provide a lot of information other than that, so that might be a good note. Maybe I'll make a note and try to include some other references, links to other sites in this table, so that you can get at that information.
I saw that it was a topic of one of the meetings that we had during the course of the project, and I'll try to go back and try to find our notes on that.
Yeah, and whoever had that question, if you could just send either myself or Mike an email, and then we can be sure and get you more information about that. I know someone wanted... I'm
going to go to the karst thing real quick.
Okay, go ahead.
The karst issue had come up earlier. I just want to show where you can find that. Here's a topic called stormwater infiltration. A whole bunch of stuff on stormwater infiltration, including the mounding page that I talked about. The wellhead protection page is here, but also is the page on karst. And so that is where you go. It's called karst, and that provides you information about why is it a concern, how it's defined, how to investigate the site, and then some general management guidelines. And so that, if you go to that site, that should be able to answer the question that you had earlier. So, I'm sorry, Anna, you were going to...
Yeah, someone had a question on if you could point out and discuss underground systems.
Okay, underground systems, you mean in the manual, I assume. They're kind of embedded within that infiltration information. So where you would see the differences are in the various tables. We don't really, I believe we take the opportunity to discuss them separately, but if you went to any of these pages, you would find, so for here, for example, underground infiltration would show up right here. So this is on the BMPs for stormwater infiltration, and it gives you a description of underground systems there. If you went to any of the, sorry for scrolling down, if you went to any of these pages that had information here, most of the tables that were constructed as part of this work order will show the different BMPs here, and underground infiltration here called out as a separate practice, and so that would be the place where you can get some comparisons. So the design page, for example, if you wanted to know design information on that, let's see if I can find it quickly here. If you go through the material specs, you'll see that sometimes it calls out underground systems where there are differences from other systems. If you don't see that there are differences from other systems, then they're essentially the same information between the different types of practices. If you go to this table, though, you'll see underground infiltration at the top here, and you'll see this will allow you to see the differences in design criteria, material specifications for underground systems. I don't know that's a good answer to the question, but basically the manual calls out those places where underground systems differ from the other systems. Otherwise, they aren't specifically discussed.
Yeah, I think it's the pertinent information should be in these tables. Either, like you said, you're in the specifications table, but there's another table that for design criteria that would have a column, that's specific to underground infiltration as well. So, two big tables that occupy significant space here.
Any other questions? Or?
I think we've gotten to most of the questions. Like I said earlier, we will be posting the Q&A. If there were questions that we didn't answer, we'll be sure and provide the answers to those questions, and we'll post all of that in the Stormwater Manual.
I just want to take 1 minute to talk about the MIDS calculator, which we are keeping our fingers crossed, but we think it will be released, version 3 will be released in about 4 weeks. So being a government employee, multiply that by 10. No, we think it'll be out by mid-January at the latest. It does have a new BMP called underground infiltration. And I'm not going to go into great detail here other than to say that that BMP is in there, and I think it's working good. We'll have a webinar in March, I believe, on the MIDS calculator, and one of the questions you'll see in the survey that we're going to send later is whether you see value in having MIDS workshops, and if there is value in that, then obviously we'll be covering this particular BMP at that time.
Someone wanted to know if we were going to be posting this PowerPoint. Well, I think it was, well, yeah, the PowerPoint for sure is going to, it's in the manual now.
What does it do?
You can, oh, I don't know. But the recorded webinar will also be posted as soon as I receive the link from WebEx. So that will be in the manual as well. What were you trying to do?
I don't know. I accidentally hit a button here.
Oh.
There was a link to where you were posting that.
Oh, right. Let's see.
So that's where you would find it.
Yeah, this is where you'd find the PowerPoint is in the table of contents, communications outreach, and then Stormwater Manual webinars. At least the PowerPoint is there right now.
It is right now.
Yeah. But the recorded webinar, we'll post that in the manual as soon as I receive it from WebEx. So I think that concludes our first webinar. We're a few minutes early wrapping up here, but I'm sure you're all happy about that. Thank you very, very much for your patience with this, and for your time and attention, and look for a survey coming from us here in the next couple of weeks, and happy holidays to everyone. Bye.
Bye.
Thank you.